Okay, so our next topic is on page 21, radicals. Okay, so it connects to our exponents. Because in exponents, we learn the new rule, right? If you get a fraction or decimal exponent, it represents a radical, right? So it could be a square root, could be a cube root. So the next topic is focusing on how to do operations with radicals, okay? So we'll start with something easier, something you might already know. But there will be some details that I added in, okay? So you understand some of the terms, okay, more precisely. So first part, introduction, okay, tells you what it's for. And next part, we'll learn how to simplify radicals. And then after you know how to simplify radicals, we'll learn how to do operations. Operation including add and subtract, okay? And then how to do multiply and divide. And there are some special products, okay, with radicals. After that, something that might be brand new to most of you is called rationalize the denominator, okay? And we'll talk about what it means and why we do that. And then we have two parts, right? Rationalize denominator, we have the one term and two terms. Okay, so that's part D. And finally, right, we get word problems. Oh, and then one more, okay, radical equation. Equation means you need to solve for x, okay? So today, right, hopefully we can, I think we will be able to finish up to simplifying, all right? So let's start with the introduction. So from exponent laws, we learn to calculate 4 squared to be 16. In this topic, we'll try to answer the following questions. So number one, is there another number beside 4, right? 4, and then when you square it, that can give you 16, right? So we have 4 squared will give you 16, right? Is there another number squared that can also equal 16?
-4.
Yeah, very good. Okay, so we have a positive 4 and a negative 4. Both of the numbers can be squared and give you 16. Excellent, okay? So the two numbers that we get, those are called the square roots. So you will always have two square roots for every number, okay? So for example, like if the question says, please find the square roots, the following number for 25, have a positive root of 5, right? Positive square root, and the negative square root. So you get two square roots, okay? But then, and then because this number is easy to find, right? 4 squared give you exactly 16. So we call this number the perfect square. Perfect square. Okay, so we'll say 16 is a perfect square. 25 is also a perfect square. Okay, what else? 36 is also a perfect square, right? The numbers that can exactly define the square roots perfectly, right? Now, the number that's not perfect square. So one number will be not perfect square. Colin, can you give me an example?
12.
Huh? Which one?
12.
12, yeah?
12.
12 is not perfect square. Very good, okay? So if it's 12, right? Something square has to be 12. It's not possible, right? It will be some decimal. So if you punch it into your calculator, Eric, can you help us? What is the decimal answer for square root of 12? Eric?
I have 3.464.
Okay, 3.464. So approximately 3.464. And the other square root will be negative 3.464. Okay, so again, you'll get a negative square root and a positive square root. Okay, both of them square can give you the 12. But then the 12 is not perfect square. Okay, so because the decimal number is rounded, right? So it's not it doesn't really represent the whole square root of it. So that's why they design a symbol to represent the square root. Okay, so they put a radical sign. Okay, for above 12 to represent the square root of the 12. Okay, so that's what it means, right? So if there's a positive one and a negative one. So for the negative, you just add a negative sign, right? For the positive, you don't need to write a sign, so it'll be just positive square root. Okay, let me put it this way, okay? So it's not so confusing. So square roots okay, if it's perfect square, it will be plus and minus 4, right? You have two of them. If it's something that's not perfect square, it still has the square roots, but then it will be in decimal. So you write it as plus minus square root of 24, which is approximately 3 point plus minus, right? You always have two roots, plus minus 3.464. Okay, so if you put a negative outside, it represents the negative square roots. If you don't put any sign at the front, it will be the positive square roots. Okay, any questions so far? Okay, so next thing, second question is, what is the difference between this one, right? Radical of a squared, square root of a squared, square root of negative a squared, and the last one. What is the last one called? Has anyone seen it before? A with a 2 bar beside it. Have you seen it before? Yosher, have you seen it?
Absolute value.
Yeah, do you know what it does?
No.
Okay, does anyone know?
Does it ignore
Ignore the what?
the and the positive?
Yeah, okay, so it actually makes the negative sign become positive, okay? So it just ignore the sign, okay? Basically what it does, right? So let's see what's the connection between, later on in grade 12, you will have a topic on absolute value. There's more to it, okay? Other than just ignoring the sign, all right? So right now, just know a brief idea how it connects to the square and square root, okay? So let's say we look at the first one. When you have a number and you square, right? So let's say we have 3 and I square, right? And I take the square root, right? So let's say if a is 3, right? So I pick a number, right? A equal to 3. Same thing will work for any number, okay? So let's say okay, a equal to 3. Then for the first one will be 3 square and square root. That will give you square root of 9, right? At the front, there's no negative sign, right? So we know we are talking about the positive square root. So this one is just positive 3. Make sense? Okay. And then the second one, if a is 3, but there's a negative sign, right? So it will be -3 squared. So when I square the bracket, it will become +9 as well, right? So it will be 3 again. Okay, and then the third one, absolute value. We call these two bars the absolute value. If I put a 3, it will be 3. Okay, it will make whatever number that goes inside become positive. If it's already positive, it stays the same. If I put a -3, it will also become 3. Okay, it does the same thing. So as you can see, the answer comes out the same, right? When I input a 3. If a is -3, it will do the same thing as well. So what I'm saying, trying to show you here is the 3 symbols there, they represent the same thing, okay? So the conclusion coming out from here is, let me write it here, okay? When you have square root of something square, you can replace it with absolute value of the something. Okay, so you can highlight that. That's the conclusion. Okay, so when they put a square and a square root, okay, they sort of canceled out, right? But it's not just disappear, it actually become absolute value. Okay, whatever inside will be like this. Okay, so for example, if you see a question like this, and then -17 and then square, then it will be the same as absolute value of -17. Okay, so this way you don't need to square and square root. It just make the inside become positive. Okay, so that's what it means here. All right, so I would like you guys to finish question 1. Question 1, find the square roots. So each of the answers will have 2, okay? One positive and one negative. All right, so please raise your hand when you finish number 1. So just to clarify a little bit, right? The 5 comes from the positive, right? And then you have the negative, right? So that's the 2 square roots. And because it's a perfect square, that's why you don't need the square root sign, the radical sign. But you always get 2 square roots. Okay, Colin, can you tell me your answer for 400?
20 and -20.
Yep. Okay, Brennan, next one.
13 and -13.
Yep. Aaron.
21, -21.
Mm-hmm. Okay, Yoshir.
14, -14.
Yeah, 14, -14. Okay, pretty easy. So these questions, you have to be careful with what they are asking. Okay, if they say, please find the square roots, right? You see it's plural, right? So there are more than one. But for the following, right, if it said evaluate, you can only have one answer, right? Because it tells you exactly whether the question wants a positive or the negative, right? Like for example, question A, right? This is a positive radical, right? So the answer is just 0.6. You don't need to put plus, positive, and negative, okay? And like question F, this one tells you it wants the negative square root, right? So this one will be -4. Okay, you don't need to put plus, minus 4, all right? And if you see a number in front, right, let's say this one, right, question E, this just means the same as -3 times the square root, right, the positive square root of 0.09, okay? And then you can continue to calculate the answer. All right, so I'll let you guys also finish question 2 now, okay? These are pretty straightforward, just evaluate the square roots. Some questions have cube roots, okay? So please raise your hand when you are done with question 2. And also pay attention to some questions has the absolute value thing, right? So whenever you see a square inside the square root, then you must right away think about absolute value, okay? You can change it into absolute value sign. Okay, there are a couple questions like that. Please raise your hand when you finish all of them. All right, question B. Let's start with question B. Brendan, what's your answer?
Just 81. Just 0.81.
Yeah, 0.81, right? So this one is a square with a square root, right? So it's the same as absolute value of 0.81, okay? Sarah, question C.
16.
16, yeah, very good, okay? This is a positive. And question D, Colin.
0.2.
Yep, 0.2, okay. And then question G, Yosher.
3,000.
Yep, 3,000, okay? It's the same as 3 times 1,000. Okay, and Aaron, H.
50.
50.
Yeah.
Okay, how'd you get 50? Aaron, how did you get 50? What's your step?
First you isn't absolute value, so it should just be like 25.
Mm-hmm. And
then
then?
you multiply it by 2, you
Yeah.
get 50.
Yeah, very good. Okay, so remember, you don't need to square the 25, right? You just remember that the square and the square root, it combined together become absolute value, okay? All right, next part. Eric, question I.
I have 2.
2, yeah, okay, so square root of 4, right, and then become 2. Nathan?
I got 2 for
Yeah.
J.
Very good. And then Brennan?
Negative 15.
Yeah, negative 15. 3 times negative 5. And last one, Colin?
15.
15. Okay, so 5 times 3. Okay, does anyone have questions about these ones? All right, so this is an introduction, okay? Remember the terms. Some of the term like perfect square, you need to know what that means. Not perfect square, right? And absolute values, square roots, okay? These are keywords, okay? Perfect squares, okay? All right, next part. Simplifying, okay? Simplify radical. So this page is talking about how do I know if I give you a radical, how do I know if it's already simplified? Or do we need to still do something to it, right? To simplify it. Just like when I give you a fraction, right? You need to be able to tell, do I need to reduce it or not, right? You need to know if it's the final answer, okay? So there are 2 rules to check to see if it's simplified. So if I give you a radical, either it's a square root or a cube root, you want to check 2 things. Okay, you want to make sure there's no perfect square inside. Perfect square or perfect cube, right? Depending on the question. Cube. Perfect cube. Okay, no perfect square or perfect cube inside the radical. Second thing, you want to make sure there's no radical in denominator if there's a fraction, okay? So for example, okay? So for example, like if you get square root of 3, right? So 3, let me circle that. 3, this number, is a perfect square, Aaron?
No.
Yeah, not perfect square. Okay, if it's not a perfect square inside, then we know this is simplified. Okay, simplified. Okay, and if you get something like square root of 50, okay, is 50 a perfect square? You're sure?
Oh no.
No, right? So it looks like it's not a perfect square. So we'll say it's not, it's already simplified. But if you look closely enough, right? If we break down the 50, I can break the 50 into 2 times 25. Then you'll see that there's a hidden perfect square inside, right? 25 is perfect square. Perfect square. So sometimes the perfect square is not just the number that you see, it's the number that makes up the number you see, right? So you have to look for that. So if there's a perfect square inside means it could be part of the number, right? Then this one is not simplified. Okay, so that's the difference between the two, all right? So 3, no matter how you break it up, right? 3 is just 1 times 3. There's no way to have a perfect square inside, right? But then 50, if I break it apart, there will be a perfect square. So that's why 50 is not simplified. Okay, is that clear? Okay, so that's for checking number 1. For number 2, you want to make sure there's no radical in the denominator. So for example, if you see something like this, right, this is not simplified, right? Radical in denominator. Okay, so this one is not simplified. Okay, so later we'll learn how to make the denominator radical go away. Okay, and right now you just need to identify whether the radical is simplified or not. Okay, so in the following question down here, right, question 3, you just need to check yes or no. Okay, yes means it's simplified, no means not simplified, and write down why. Okay, so you can say because of perfect square inside, or square perfect cube inside, or is it because radical in denominator? Okay, you can use reason 1 or 2. Okay, just write down number 1 or 2. So for example, number 1, or question A is no, right? Because there's a perfect square, right? 4 is a perfect square. So because of reason number 1. Okay, so that's what you do for the rest of them, all right? So finish the rest of the question and then raise your hand, okay? Answer yes or no and write down why. Okay, you should be done by now, right? This is just yes or no question. Please raise your hand. Okay, so each one of you should get a chance to answer. Okay, Eric, are you done? Okay, let's start with Yosher. Question B.
Yes.
Okay, yeah, okay, so yes, no reason then. Okay, yes. Okay, and then question C, Brennan.
No.
No, because,
Reason number 1.
and how come? How come reason number 1?
Because we can change it to a certain number times a perfect square inside the radical.
So like what times what?
Like 4 times 6.
Yes, very good. Okay, so
Like-
4 times 6, there's a perfect square of 4 on the inside. So you know it's not simplified. Okay, next one, Colin.
No, because there's a radical in the bottom.
Yeah, so reason number 2. Okay, next one, Aaron.
No,
No, why?
because it can't be divided, or it cannot be simplified to a point where it's a perfect square.
Your no means is it simplified or not?
Oh, it's
not-
not simplified, right?
It's not simplified. So if it's not simplified, can we find perfect square inside?
I'm not sure, but probably no.
So if there's no perfect square inside, then it is simplified.
Oh,
Okay, so you have to get that clear. If there is no perfect square inside and there's no radical in the denominator, then it is simplified. Okay, then the radical is simplified. So you want to make sure 2 no's, right? So like 34, how do you break this down, Aaron?
there's 2 and 17.
Yeah, 2 and 17. So 2 times 17, is 2 a perfect square?
No,
Okay, is 17 perfect square?
no.
No, right? So there's no perfect square inside at all. So we know it's simplified. Does that make sense?
Oh, okay.
Okay, the yes and no is just saying it's not simplified or not or simplified. Okay, not simplified. Which means we need to do something later. Okay, yes means it's already simplified, which means it's already the final answer. You cannot do anything more. Okay, so yes means it's done. No means we still need to do something later. Okay. Right. Question F, Sarah.
No.
No. Okay. So not simplified because
There's a radical at the bottom.
yeah. So reason number 2. Okay. Question G, Nathan.
No.
No, because
Number 1.
number 1. How?
Like
How
you
do
could do like you could do 4 by times 6.
4 times 6, but this is cube root though,
Oh,
right? If it's cube root, we are looking for perfect cube inside.
you could do 3 and 8.
Okay, which one is the perfect cube?
8.
Yes, very good. Okay, so 8 is a perfect cube.
Yeah.
Yeah, so that's why it's not simplified. Okay, question H, Eric.
I think it is.
So yes,
Like, it's not.
is it simplified or not? Eric?
I don't think so.
It's not simplified.
Oh,
Eric?
let me double check my answer.
Okay, okay. Keep your mic on, okay? Yeah, very confusing, right? You're checking, is it done or is it not, right? Just like when you ask yourself, is this fraction simplified or not? So you just need to check two things. You want to make sure if there's no more perfect square or cube inside, then it's done, okay? Done means simplified.
No, because it's number 1.
So it's not simplified.
It's not.
Okay, then can you break it down for me? Tell me why.
It's I think it's 3 times 3
Three,
times 'cause-
3 times 3.
oh wait, never mind. There's only 2 3s.
So how do you break it down? 3 times 3 times what?
2 times 7.
And times 7?
Yeah.
3 times 3 times 7.
I misread it because I thought it was square root.
Okay. 3 times 3 times 7 is not 126 though.
There's a 2.
Oh, 3 times 3 times 7 times 2?
Yeah.
Okay. So that's 63 times 2. Yeah, okay. So there's no perfect cube, right? Because the cube root, we want to have perfect cube inside. So is it simplified or not? Eric?
I think so.
Okay, so this one is already simplified. Okay, is everyone clear how to check? So this one is yes, it's done. Okay, it's simplified. So we don't need to do any work at all. Okay, whatever that I give you is already finished. There's nothing else to do. Okay, that's what it means by simplified. If it's not simplified, which is what you will get for homework next week, is you need to simplify it, okay? Make something not simplified into simplified. All right, that's what this exercise is for, okay? For you to check whether you need to do something or not. Okay, so your homework won't be on simplifying radical. It will just on some exponent and evaluate simple things like on page 21, okay? So I'll see you guys next week and have a good weekend.
Bye, Jason.
Bye-bye.